So for 5.5, we're going to be looking at properties of rational exponents. So we're going to have several definitions, so make sure you have your blue paper handy and a highlighter. We are going to simplify expressions with negative exponents. We're going to simplify expressions with rational exponents, which you will be defined in a second. We're going to write negative powers as positive powers. And we're going to write rational powers using radicals, going back and forth. We're also going to find what we call the nth root of a number, and we're going to write an expression in radical form. You have key terms here: cube root, index, nth root, radicand, and rational exponent. So we are going to skip the first part of problem 1 and turn straight to page 339. Okay, so guys, we're first just going to be talking about powers of 10, so we're skipping the first part of problem 1, and we're going straight to the second part, so number 2 on page 339. I'm going to do the first one for you, and then we're going to see if you guys can do the rest on your own. So what we want to do is we want to use powers of 10 to write our answers as a quotient of powers and then a single power. So I'm going to give you a rule of exponents here. So can I write 100 as a power of 10? 100 is 10 to the what power, guys? 10 to the 10th? 10 to the second, right? 10 times 10 is 100. What do you guys notice about the exponent and how many zeros there are? The exponent is 2 and there's 2 zeros. So how do you think I can write 1,000 with 3 zeros as a power of 10? 10 to the third. Good. So there's 3 zeros and the exponent is 3. For tens, it always is that way. Let me zoom in just a little bit. Okay. So how can we simplify this exponent? Do you guys remember the quotient rule for exponents? If I have exponents in a fraction, do you guys remember what I do with them? Does anybody remember? I think I heard somebody say it. Well, in pre-algebra, yes, in pre-algebra, I know that a lot of the teachers, we had you write every single one out, so 10 times 10 times 10 times 10 or whatever, and then you would cross them out. But do you guys remember the shortcut that we learned after that? You subtract them. So we're going to rewrite this as 10 to the power of, what is 2 minus 3? Negative 1. And what did we learn you do with a negative exponent? You put it over 1. So we could rewrite this as 1 over what? As 1 over 10. Remember, the negative exponent means that this guy didn't pay his rent, so he has to move downstairs, and then he becomes positive. Okay? What I really want is this as your answer. 10 to the negative 1. That's what I'm looking for. Okay? So you just subtract your exponents. All right? So here's what I want you guys to do. Do B and C on your own, and let's see how you do in the next minute or so. Okay, so B is, I have just a 10, so that's 10 to the what power? 10 to the first power, over 1,000, which is 10 to the third. So what's 1 minus 3 give me? Negative 2, so that's 10 to the negative 2, right? Okay. What about 1? How could I rewrite 10 to a power to get 1? 10 to the 0. Over 1,000, which is 10 to the third. And what's 0 minus 3? Negative 3. So then number 3 asks, how can we write a power with a negative exponent as a power with a positive exponent? We just talked about this in a second ago. If you have a negative exponent, what do? You put 1 over it, and then what happens to the exponent? It becomes positive. So you move negative exponents to the denominator. And you make them positive. Okay, so you move negative exponents to the denominator and you make them positive. That's what we do with negative exponents. This is just kind of like a little review for you. Okay, so problem 2, boat stability. Let's read this together. The weight of a boat depends on its beam width. An equation that relates a boat's weight to its beam width is W equals 64 times B over C to the third power. Why don't you put a box around that, because we're going to be using it kind of a lot in this problem. Okay, so just put a box around it so that you know that that's what we're working with. W is the boat's weight in pounds, so underline that so we know what we're plugging in for W. B is the beam width in feet, so underline that so you know that what we're plugging in for B. And C is what we call the capsize factor. When the capsize factor is less than 2, the boat is less likely to capsize or turn over. So if the capsize factor is less than 2, it's less likely to turn over. If it's more than 2, the boat is more likely to turn over. Okay? So this is an equation that sailors actually use, or engineers use, when they're building boats. Okay? So let's suppose that a boat has a capsize factor of 3 and a beam width of 6 feet. What is the weight of the boat? So we're going to do this together. First of all, let's plug everything that we know into the equation. So the weight is what we don't know, equals 64 times, what are we plugging in for B? 6, the beam width. Over, what are we plugging in for C? 3. All of that is being cubed. Okay, order of operations tells us that we do what first? Parentheses. So this is 64 times what? 2 to the third power. And then after parentheses, what do we do? Exponent. So this is 64 times, what's 2 to the third, guys? 8. So our weight is what? 64 times 8 gives me 512. So the boat weighs 512 pounds. Yeah. It does get a little bit harder, but we're starting out with something you know how to do. So all we're doing is plugging stuff in to the boat to figure out how much it weighs. So let me have you guys do number 2 on the next page. So on the next page, do number 2. This one says that the boat has a capsize factor of 3 again, but this time the beam width is 9. Find the weight of the boat. So go ahead and do that on your own. Okay, so compare your work to mine. I plugged in 9 for the beam width and 3 for the capsize factor, which gave me 64 times 3 cubed. 3 cubed is 27, and 64 times 27 is 1,728 pounds. Yes? Yes. Easy, right? Okay, so look at number 4. Let's skip number 3. Suppose that the boat has a capsize factor of 2, and we know that it weighs 1,000 pounds. So what don't we know in this case? The beam width. So where are we going to plug in the weight? In W. So this is going to be 1,000 equals 64 times, do we know what B is? No. No, so keep it as B over what? Over 2, and all of that is being cubed, right? Okay, that's all they wanted for number 4, part A. They wanted us to write an equation to determine the beam width of the boat, so just plug everything in. So part B wants us to transform that equation to isolate the variable with its power on one side of the equation. So let's take a look at what we have here. I'm going to rewrite the equation we just wrote so that I can work with it. Okay. So remember, when we cube a fraction, that means that we're multiplying that same fraction, b over 2, how many times? 3. So let's rewrite what we have. 64 times b times b times b, what's that give you? B to the third. And 2 times 2 times 2 gives me 2 to the third, which is 8. So do you guys agree that this is 1,000 equals 64 times b to the third over 8?
Yeah.
Okay, so I just cubed the top and the bottom is what I did. Now, we can't simplify this b to the third over 8, but can I, 64 is the same as 64 over, can I cross reduce here?
Yes.
How many times does 8 go into 64? 8. So this is 1,000 equals 8b cubed, yes? So all I did was I cross-reduced because these two numbers will reduce. So 8 over 1 times b to the third is the same as 8b to the third. What would you do to get b to the third by itself? Divide both sides by 8. So that gives me b to the third equals what? How many times does 8 go into 1,000? Actually, it does. Mm-hmm. 125 times. Mm-hmm. Oh, yeah, because I'm that good. I already did the problem. Okay. So that's what I wanted us to do in Part C. Or, I'm sorry, Part B. So Part C wants us to determine the value of b. You need to know the number that when multiplied by itself 3 times equals 125. What is that number? So what this is saying is that b to the third power is equal to 125. So we're looking for a number times itself 3 times to give me 125. Does anybody know what it is? 5 times 5 times 5 gives me 125. So the number that we are looking for is 5. Okay?
Oh, I get it. I got really happy.
Okay. So let me reiterate. b to the third equals 125. This is saying that some number times itself 3 times gives me 125, right? I wanted you to figure out what that number was. Yeah, just from practicing, and then somebody got it really fast, so, woo! Okay, so 5 times 5 times 5 gives me 125. This one, you will eventually, by the end of the unit, you will have this one memorized. You guys already have 2 to the third memorized, right? 2 times 2 times 2 gives you 8. What about 3 to the third? 27. Does anybody have 4 to the third? 64. So the first 5 you should probably have memorized, the first 5 cubes. Okay, we're going to define this in just a second. So let's use common sense here. This is telling me that the beam's width to the third power equals 125. We figured out what that number is. So what is the beam's width? 5 what? 5 feet. So write that out in Part D. The beam's width is 5 feet. Okay, does that make sense?
Wouldn't the beam would have to be changed to divided by 2 in the beginning?
But we took care of that because we already cubed it and then divided the big number by 2. Solving, isolating the variable gives us our answer. So what you guys just did is you took what is called a cube root. So this is your first definition. Okay? So on the next page in that notebook spiral page that they have, we can say that a number b is a cube root of a if b to the third equals a. And then it gave us our example that we just used. So 5 is a cube root of 125 because 5 cubed equals 125. Okay? It's the same idea as a square root, but this time we're multiplying 3 times. Okay? I also want you to write this or highlight this in your book. A cube root is indicated by this symbol. It's a square root, but inside the square root, let me zoom in so you can see it really, really good. Inside the square root is a little 3. Okay? So it's the same idea as a square root, but inside is a little 3. The number 3 is called the index of the radical. Okay? The index tells you how many times I'm multiplying the number by itself. Okay? So we would say that the cube root with the little 3 of 125 equals 5. So Part 5 are a couple examples for you. In A, it wants me to take the cube root of 8. So that means a number times itself 3 times to get 8. What number times itself 3 times gives me 8? 2. So the answer would be 2. Okay? Same idea as a square root, but this time we're multiplying 3 times. Part B is a little tricky, and even my high schoolers have trouble with this. So let's see how well you guys do. I'm looking for the cube root of negative 27. What times itself 3 times would give me negative 27? Negative 3. You guys, the high schoolers can't get that. No, they don't like the negative on the inside, that's why. So, because if you think about it, negative 3 times negative 3 gives me positive 9, but times negative 3 again gives me negative 27, okay? So this little index tells you how many times you're multiplying the answer by itself, and the inside tells you what you want the answer to come out to, okay? Does that make sense? Okay, so we can do this with not just cube roots. We can do this with larger roots as well, which I was kind of talking about in a second. So we can extend this idea of square roots and cube roots to solve equations. If n is a positive number, then a number b is called an nth root if b to the n equals a. So now we're talking about this in general terms. So n will actually be a number, 3, 4, 5, 6, 7, but we always have to be able to write a mathematic definition in general terms. Okay, so n is actually going to be a number. It's not going to stay as n, but we're using it for any number right now. Okay. So for example, 2 is the 4th root of 16 because 2 to the 4th power equals 16. So that's just what we're saying. 2 is the 4th root of 16 because 2 to the 4th power equals 16. 2 times 2 times 2 times 2 gives me 16. Okay? So we're going to complete each statement down below. The number 3 is the 5th root of 243 because 3 to what power equals 343? 3 to the 5th power. So 3 is the 5th root of 243 because 3 to the 5th power is 243. Okay? So do B and C on your own. So part B, we say that the number negative 2 is the cube root of negative 8 because 2 to the 3rd equals what? Negative 2 cubed equals negative 8. Okay? The number 4 is the what root of 4,096 because 4 to the 6th equals 4,096. So what root is 4? The 6th root. Okay, does that make sense? Just going back and forth. Okay, so let's look at one last definition for today. Actually, no, we have one more, but I don't think we're going to get to it. The nth root of a number, a, is designated as n root a, which we're going to look at. N is the index of the radical, and a is the radicand, which is the value within. So the definition of radicand is the value within the radical. Okay, that's all I need you to write. The radical is like the square root symbol. It's not always called a square root because that's a specific type of radical. That actual symbol is called the radical. Okay, so we're actually going to do some roots just to practice. Number 7, they do part A for us. So the square root still looks exactly the same. It does not have an index on it. It just stays as a square root, but everything else does have an index, okay? But the square root is still exactly the same. So the square root of 100 is what, guys? 10, because 10 squared equals 100, right? Yeah. I'm going to do B with you, and then I'm going to have you guys try and figure out C and D, and then we'll be done for the day, okay? The cube root of 216, what times itself 3 times is going to give me 216? Does anybody have an idea? 72 times itself 3 times is going to give you something way bigger than 216. It's going to be 6. Okay. You'll have a little more time to work on these. So is equal to 6 because 6 cubed equals 216. So 6 times 6 times 6 gives me 216. So I'm going to give you guys just a couple minutes. Do C and D. See if you can find the 4th root of 81. And the 5th root of negative 32 for me. So guys, what does the fourth root of 81 come out to?
3.
3, because 3 to the fourth is 81. This was the tricky one. What is the fifth root of negative 32? Negative 2, because negative 2 to the fifth is negative 32. Does this make sense, guys?
Yeah.
Okay, good.